Let's try out this problem called longest common subsequence. Let's have a read. Given two strings text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. Essentially, we removed B and D from it. And so we looked at ACE and the relative position of AC and E did not change. A common subsequence of two strings is a subsequence that is common to both strings. All right. So the first example is ABCDE and ACE. We can see ACE in this relative order is already present in text one. So the longest common subsequence will be ACE, right? And its length is 3. So text one and text two both are ABC. So obviously the longest common substring would just be ABC, which is whose length is 3. Between ABC and DEF, we do not see even a common characters. Forget about common subsequence. So the length is 0. So how do we look at solving this? Let's come to maybe the code. Let's try it out on a whiteboard, and let's take a variant of the first example that's given to us. So the first example, one of the strings that is given to us is A B C D E. Another string is ACE, but let's modify it just for understanding. So let's say it's A, maybe some F, G, C, and then maybe H, J, E, K, L, maybe something like that, right? And obviously we can see between both the strings, the longest common subsequence is still ACE. So how do we build that? So how do we build, let's call it longest common subsequences LCS. And well, there are these two strings. This has 1, 2, 3, 4, 5 characters. Its length is 5. This guy's length is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So let's define LCS of index 1, which is the index in, or the, okay, let's not call it index. Let's call it um, longest common subsequence of S1 and S2 is what we're trying to find out, right? So the ways to look at is there are two cases. If the last character matches, let's start from the last, right? If last character match, so both the strings, so last character here E and last character here L, if they match or they don't match, right? So there will be two cases. One is that they match, other is that they don't match. So if they match, then what would be the longest common sequence? It would be one that common character plus LCS of, well, remove the last character. I don't know how to represent it. Let's call it S1 minus 1 and S2 minus 1 in a way to represent that. Or what you would do it is you would remove one of the characters from either of the two strings. So, and there are two options, right? So you go then max, either you take S1 as is and reduce S2, or you take S2 as is and reduce S1, right? So that's the general idea. Let's convert. Let's use this. So essentially, we'll denote this maybe in a 2D array. So this representation, we could use a 2D array to represent that, and we can have something called as LCS IJ. And what this means is LCS when considering the first I characters of text one and first j characters of text 2, right? And if you build it, eventually what you want to return is LCS of text one's length, which is I don't know, L1, L2. This is what we eventually want to return. Let's try and build the logic based on that. So what we're really saying is we're trying to build the logic What you're saying is LCS of ij. So what does this mean? This means longest common subsequence considering the first I characters of text1 and first j characters of text2. That's what this represents. Okay. So I can vary from 0 to text1's length, and obviously j can vary from 0 to text2 length. And what happens is, so ultimately LCS of ij equals to, so there are two cases. One is if the characters match. So if, uh, let's call it S1 or text1, so S1 at I, if it is same as S2 at j, then they match. Then it would be, well, one character reduced from both, I minus 1, j minus 1 plus 1, right? Remove the last character from both. Or if that's not the case, then remove one character from either of them and get the max of both. So max of LCS of, it would be like ij minus 1 or LCS of I minus 1 j, right? That's what we're trying to build. Okay, so that's our logic. Let's try to build it up. So what we're doing it is we're using some space of 2D array, calling it LCS equals to new int text1.length. It varies from 0 to text1.length. So let's give one extra one, right? And text2.length plus 1. Now, if I or j is 0, that means you did not take any character from one of the two strings. Then it's already 0. So we're really interested in taking at least one character. So we'll do for int I equals to 1, I less than or equal to text1 dot length. So eventually what I'm saying is just I want to return LCS of text1 dot length, text2 dot length, which is I considered all characters of both the strings, right? And then once I consider all characters, what is the final LCS, the longest LCS, longest CS that I get? So I equals to 1 and then equals to text1 dot length. Let's make it simpler and let's convert them to arrays. So let's do uh, let's call a char array s1 equals to text1 dot to char array, and similarly let's have s2 as well. And let's represent in terms of this s1 and s2 just for ease. So we want to return s1 dot length, s2 dot length, right? And here also let's represent in that sense. So the same, but yeah, s1 dot length plus 1 and s2 dot length plus 1. Oops. So now we go from for int I equals to 1, I less than equals to s1 dot length, I plus plus, and j equals to 1, j less than equals to s2 dot length, j plus plus. We have to check if the characters match. So what would be the last character? Would be I minus 1, j minus 1, right? So if s1 of I minus 1 equals to s2 of j minus 1, then their characters match. Then LCS ij would be equals to what? Would be equals to 1 plus LCS of I minus 1 j minus 1, and else LCS of ij equals to max of, considering removing one character from each at one time. So LCS of either I j minus 1 or I minus 1 j. So that is the entire logic. Let's run and see if there are any issues. It gets accepted. Let's submit. It gets submitted as well. You see the space complexity isn't that great. Time complexity is all right. So if you talk about the space complexity of this problem, what is the space complexity? Well, we're building a 2D array here of length m times n. Why are we building that? Like if at any point LCS ij, what do we really need? We rely upon I minus 1 j minus 1, which is like one row above and one column above, one column to the left. And what is or ij minus 1, which is just one column to the left, or one row above on the same column, right? So if I am on the nth row, I just really need n minus 1th row. That's all. I don't need all the previous rows, right? So we could potentially modify it a little bit because we only rely on the previous, we only need the previous row if you really look at it. So if we try and modify it based on that, so instead of using this 2D array, we just use like the a row. So we can have something called, we'll start with let's say the previous row, and the previous row we give a new int. It was text2 dot length. If we just take one row here, or other s2 dot length, okay, and then inside we, for every row, now we build this current, what is the value for this current row? So we build this current row, and current row will depend upon either, so now here instead of LCS ij, so this LCS ij I can instead say, so current row of j is 1 plus previous row, previous column, right? So previous row is this, so previous row j minus 1, right? And similarly this we can replace with current row of j equals to either the previous column in the same row, which is current row j minus 1, or the same column in the previous row, which is previous row of j, right? Simply that. At the end, and now when this row is done, now this current row is what I'll assign to the previous row, right? So previous row now becomes current row, so that for the next row, this will act as the previous row. So at the end, my last row's value will be in this previous row. So I can then return previous row, because previous row is actually the last row at the end of it, right? So the previous row and last column, which would be s2 dot length. That is one optimization we can do. Let's first run and see if it works. Okay, let's fix what the issue is. Index out of bounds. So what is the mistake that we did? So we are looking current row. We are doing this was previous row, which is s2 dot length, which is all good. Current row, it was either, so this was the case where everything matched. So we did I minus 1, j minus 1. So previous row j minus 1 was fine. And what about this? So this is current row of j equals to math.max of either the current row of j minus 1, which is correct, or previous row of j. So somehow I think it gets confused with what and why. Okay, so s1 dot length is correct, s2 dot length is correct. We compare the characters, that's fine. This works all right. What is the length of current row? Is always, yeah, that's a problem, right? We want to give it +1. All right, let's run again. Okay, submit and see if it improves the space complexity at all. And it does significantly improve the space complexity. One thing that comes to mind is, so essentially the space that we're using is the length of the second string now, right? And 2 times that, okay, because for current row and for previous row. But why don't we choose a one which is just a smaller string, right? That can even save some space, a little bit more. So what I'm saying is consider text2 as the one which is the smaller one. So in case text2's length is bigger, so if text2 dot length happens to be greater than text1 dot length, then I will just replace them. So I will make a call like that, and I will do text2 comma text1. So that text2 is always a smaller one, and that will mean that I'll have lesser space used for the lesser auxiliary space used. All right, let's submit. And this seems good. All right.